I'm Chris Anderson at the EEWeb Tech Lab, and today we'll discuss ZMDI ZSSC416x and ZSSC417x family of sensor signal conditioners. The ZSSC416x and ZSSC417x provide highly accurate amplification and calibrated correction of sensor data for resistive bridge and voltage source sensors. The family features CENT 3.0 based ICs and is designed for use in automotive applications, with available diagnostic info, rugged circuit protection, and excellent electromagnetic compatibility. The family aids designers by lowering power consumption, reducing component count, and saving time spent calibrating sensors. Additionally, the availability of dual bridge inputs also reduces system complexity and footprint. All of these are important considerations in modern automotive applications, where power and space come at a premium. The ZSSC416x and ZSSC417x feature a widely programmable gain amplifier, a 12 to 18-bit ADC, an integrated temperature sensor, non-volatile memory to store calibration coefficients and configuration data, and a 16-bit RISC MCU that uses the calibration data and temperature measurement to compensate for offset, thermal drift, sensitivity variations, and non-linearity. End-of-the-line digital calibration over the I2C or one-wire interface improves calibration accuracy and reduces assembly cost and complexity. So on the evaluation kit for the ZSSC family, we have the communications board, which interfaces between the PC and the IC. We have the actual ZSSC board, which houses the IC, and that's sitting inside this socket. What I really like about this board is ZMDI gives you access to all of the pins. So you can plug in your own sensors, and you get access to the temperature sensor, as well as any other pins that you need to. So you can really evaluate whether or not this is suitable for your application. The third board acts as a pressure sensor. It's really just a potentiometer though. On the software side, on the first time you'll come in and you'll load an XML file, and that will load in some basic parameters. And you can check those in the quick settings and then load those into RAM, write all to RAM. And then you'll want to come in here and calibrate your sensors. I've already done that for both the pressure and temperature sensor. And so those are good to go. I've already written those out. And you can also see that I'm actually running the software now. And so if I adjust the potentiometer for the pressure sensor, you can see in green, that's the calibrated measurement, and in blue, the raw measurement. And so you can see those adjusting up and down. The pink graph is the internal temperature sensor. So if I put a heat gun to that, you can see the temperature rise up. Now I'm going to go ahead and stop. Now what we want to do is grab this hex version of the temperature data. And actually we're going to run it again so that we can get a fresh version, because it's been cooling off, of course. So if we say it's sitting at about 0x2e25, so plug that into the calculator. Now the I2C data is 15-bit and the CENT data is 12-bit. So we're going to divide this by 8, and then we're going to go compare this to what we see over the CENT interface. So if we enter normal mode, this additional window will pop up, and we're going to try to freeze ID 23 as it comes down through the CENT data. So we can see 05BE, which isn't far off from 5C4. So that's just a different representation of the data, and you can see some other channels here for the CENT mode data as well. Now there's a couple other options we have here. As I mentioned earlier, the IC does have some non-volatile memory, so we can go into the NVM status, and you can see that I've committed 7 pages, and I have 19 pages remaining. So the next time I plug this in, all of my calibration data and all my settings will come back the same. So I won't have to go through that process again. If I wanted to, I could go back to the quick settings and calibration pages and send that data again. But since I haven't changed anything, that would just be burning up some free NVM pages. And if you really want to get into the low-level access, the command console gives you a terminal-like interface, and this is talking to the communications board, and through that you can talk to the ZSSC IC. If I send it a V command, that'll just return the version of firmware that's running on the communications board. ZMDI ZSSC416x and ZSSC417x offer a variety of benefits and sensing applications, especially those in automotive designs. For more information, visit zmdi.com.